In our previous session, we were discussing about if else loop and a case statement. We have seen how to design your multiplexer and how to design your demultiplexer using if else statement and case statement, and how your design is going to look like if you are using a case statement, and how your design is going to look like if you are using an if else statement. This and all things we have seen in our previous session, right? Now, in this session, we will start with another combinational designs, that is nothing but our encoder, and we are also going to see about our next one is decoder. Okay, so we are going to discuss about this encoder and decoder. Let us see how to design this encoder and decoder. Now, coming to this encoder. So our encoder truth table, first of all, let me write down this encoder truth table. So I'm going to design this encoder in my behavioral modeling. Okay, so let's say this is my D3, D2, D1 and D0 are my inputs, and outputs are Q1 and Q2. This is my encoder truth table. So coming to this encoder, if my inputs are equal to 0, 0, 0, 0, 1, my output is nothing but 0, 0. And if my inputs are 0, 0, 0, 1, then my output is nothing but 0, 1. And 0, 0, sorry, it is 0, 0, 1, 0 and 0, 1, double 0. Then my encoder is equal to 1, 0, output is equal to 1, 0 and 1, all zeros. Then my output is equal to 1, 1. Okay. So this is nothing but my encoded truth table. So depending upon my input, I am going to get my outputs. Okay, so where your input, this first input has this first input is given first, and if it is given, then we are going to get 0, 0, and followed by if we are giving 1, 0, 0, then we will get double 1. Okay, so let us try to design this using our Verilog behavioral modeling. So it's a simple design, we can design it very simply. Let me show you. First of all, let me create a file which is known as encoder. So next, create file and encoder underscore. I'm going to design a 4:2 encoder. Okay, and press OK and finish. Press OK and press yes. So a file will be created. A encoder file will be created. Let us wait for the creation. Yes, so this is our encoder file. Now let us open this file. Now in this encoder, first of all, let us write down our inputs and outputs. Let me zoom in a little bit so that it will be. So inputs of this encoder is, one of the input is D0, comma, D1, comma, D2, or else we can use a vector. Simply we can use a vector 3 down to 0, D in, and output reg 1 down to 0, y. So these are the inputs and outputs of my encoder. Okay. Now within an always block, what I'm going to write down is, if din is equal to 4 tick binary 0, 0, 0, 1, then my output y is equal to 2 tick binary 0, 0. Okay. I'm going to write down my encoder in using if else loop. Else if my din is equal to 4 tick binary 0, 0, 1, 0, then my output y is equal to 2 tick binary 0, 1. Okay, and one more combination, let me write it down here. Else if din is equal to 4 tick binary 0, 1, 0, 0, then my output is equal to 2 tick binary 1, 0, and if my input, else if din is equal to 4 tick binary 1000, then my output is equal to 2 tick binary 11. So this is my encoder design which I have written, and within an always begin and block I should write begin and followed by end. So this is how I am going to write down the code for my encoder, and let me save this first and let us write down the test bench. Just simply if my input is equal to 0001, my output is equal to 00. If it is 0010, then my output is equal to 01, and it is 0100, then my output is equal to 10, and 1000, my output is equal to 11. Okay. Now let me write down the test bench for this design. So how to write down the test bench? Just create simulation source and press next and create file. Here tb underscore encoder is my test bench file name, and press OK and finish. So a simulation source will be created here, encoder underscore 4:2. Let us open this file. 4 is to 2 underscore TB. Let us open this test bench file. So any doubts in the design? Is the design clear? So let us try to write down the test bench for our encoder. So for writing down the test bench, we will declare the variables reg d underscore in and wire 1 down to 0 y. Okay, these are my inputs and outputs of my which are my inputs and outputs I'm going to connect. And let me copy the design name. The design name is encoder underscore 4 is to 2. Let me copy this and paste it over here and dot. So it is d in comma y. So this is my input and my outputs I have declared d in comma y. Now, what is the next step? Next step is initialize my input variables and output variables. How to initialize my input variables and output variables? Within an initial beginning block, initial begin din is equal to 0. Simply din is equal to 0 and end. Okay. And this is my initialization, and next step is applying my inputs. How to apply my inputs? Din is equal to 4 tick binary 0001. This is one of the input. And let's say after one time unit, I'm going to apply one more input. Din is equal to 4 tick binary 0010. This is one of the input. And next hash 1, din is equal to 4 tick binary 0100. And after one time unit, I'm going to apply din is equal to 4 tick binary 1000. Okay, so this is how I'm going to apply my inputs to my encoder using the test bench. Now let me save this, and after saving this, make sure that you have set it as stop. So just right click on this encoder test bench and click set as stop. After setting it as stop, just click on run simulation and run behavioral simulation. Yes, so this is the encoder output which we are getting here. Now let's say if we are giving our input as 0001, then our output is nothing but 00, which we are getting. Okay. Now if we are, let's say if we are providing, let me zoom in a little bit. Now, if we are providing 0010 as our input of our encoder 0010, then our output is nothing but 01. And if our input is equal to 0100, then my output is equal to 10. And if my input is equal to 1000, then my output is equal to 11. So, but with this, I have verified that my encoder is working correctly. Okay. Yes. So any doubts or any queries in this encoder design? And previously when we were doing this multiplexer, let me show you one case here. So when we were doing this 4 cross 1 mux, let me open this design 4 cross 1 mux. And if we were using case statement, right? So let's say if I'm removing this last case, that is 2 tick binary 1 1, let me save this and see the let us see the synthesis design, how it is going to look like. So I'm going to press open elaborated design and press OK. Yes. So what I've done simply is I've removed this particular condition in the case statement. The last condition I have removed. So if I'm removing this last condition, then as discussed, when we were not writing any default statement in the case, then a latch will be formed. So in the schematic also we can see a latch is formed whenever we are missing any one of the condition. Okay. So if we are missing any condition, then we are then basically your tool is going to form a latch. Okay, so to avoid this particular latches to be formed, then you should always mention default statement. So if you are mentioning default statement, then no latch will be formed. So let's say y is equal to 0. Okay, let me save this and reload this again. Let me save this and reload this again. If you're not mentioning this default statement and by mistakenly if you are missing any statement, if you are missing any statement to be written, then a latch will be formed as shown in the diagram. Now let me comment that, let me add the default statement. Let's see how your synthesis design is going to look. Now let us see the schematic, how it is going to look like. See, so this is your schematic. So no latch has been formed. So please remember that whenever you are using a case statement, then by mistakenly if you are missing any particular case, then tool will form a latch. Okay, latch is nothing but your output is just simply connected to the input. Okay, so to avoid that particular latch, you should mention the default statement. So if you are mentioning the default statement, then no latch will be formed. Okay. Yes. So is it clear? So no unwanted latches will be created if you are using a default statement, but if you are not using a default statement, unwanted latches will be created by the tool. Okay. Yes. So shall we move forward? So let us see one more design, that is our decoder. So we have completed our encoder design. Now let us see how to design your decoder. So create file decoder underscore 2 to 4 decoder. Let us see and press OK and finish. So a 2 to 4 decoder has been created. Now let us open this and let's start coding this 2 to 4 decoder. Open file. So the inputs of your decoder are input 1 down to 0, D in, and output 3 down to 0, Y. So these are our inputs and outputs of our decoder. Now, so always at the rate start, it is a combinational circuit. Begin. If my D in is equal to 2 tick binary 0 0, if my input is equal to 0 0, then my output is equal to 4 tick binary 0 0 0 1. This is my decoder functionality. And else if my D in is equal to 2 tick binary 0 1, then my output y is equal to 4 tick binary 0 0 1 0. Okay. And else if D in is equal to 2 tick binary 1 0, then my output y is equal to 4 tick binary 0 1 0 0. And else if my D in is equal to 2 tick binary 1 1, then my output is equal to 4 tick binary 1 0 0. So this is my decoder, 2:4 decoder. And let me save this and run this. Let us see what are okay. And I should make sure that it is saved as reg. Okay. Then only you will get your out. Then only your code will be compiled. And let us save this. And let us write down the test bench for this decoder. How to write the test bench? Let us again write down. So add source, add create simulation source, and press next. Create file decoder 2:4 underscore TB is my decoder test bench I'm going to create and finish. So I've created the file for my decoder test bench. Let me open this file. Now let us write down the test bench for this decoder. Reg 1 down to 0, D in, comma reg, and we have output as, let us connect it as wire 3 down to 0, Y. Okay. So these are my inputs and outputs which I am going to connect, and let me initialize them. Initial begin d in is equal to 0, simply d in is equal to 0, and end. And I'm going to drive my inputs. How to drive the inputs? Initial begin d in is equal to 4 tick binary 0 0 0, and after some time unit, sorry, d in is only 2 tick, right, 2 bit, 2 tick binary 0 0, and after some time unit I'm going to apply them. D in is equal to 2 tick binary 0 1, and D in is equal to 2 tick binary 1 0, and D in is equal to 2 tick binary 1 1. So these are the inputs which I have applied to my design. Now let us save this and let us make it as top, and after that we will run the simulation. So where is this decoder underscore 2 underscore 4 TB? Let us save this. First of all, let us make it as a top and run the simulation. I think I haven't connected my design. I haven't connected my design. I should instantiate it. So that's why it's not showing anything. Let me instantiate it first. DUT and D in comma Y. This is my instantiation which I've done, and let me relaunch it one more time. Yes, let's check our output, how it is going to look like. Yes, so this is our output. Let me zoom in a little bit. So initially my input is equal to 0 0. So my output is equal to 0 0 0 1. And my if input is equal to 0 1, then my output is equal to 0 0 1 0. And if my input is equal to 0 1 0 0, then my output is equal to, sorry, if my input is equal to 1 0, then my output is equal to 0 1 0 0. And my input is equal to 3, that is nothing but 1 1, then my output is equal to 1 0 0. So this is how I'm going to verify my decoder, whether it is working correctly or not. Yes. So any doubts or any queries in the decoder? Now, so this is my decoder design and encoder design. So this is how I'm going to design my decoder and encoder. Now, so we have seen your case statement, if statement, while statement, for loop statement. This and all things we have discussed in our previous sessions also. Okay. Now let us discuss about one more statement which is known as case X. So there is one more statement which is known as case X. Normally we have seen your case statement. So if you are writing simply case A, and you are, let's say for example, 2 tick binary 00 some statement you are writing, and 2 tick binary 10, for this you are writing some statement, and for 2 tick binary 01, 2 tick binary 10, and 2 tick binary 11, like this you are writing some case statement, right? Now if your a value is equal to 2 tick binary 11, then this will be matched with this statement and this line will be executed. Or else if your a is equal to 2 tick binary 01, then this will be matched with this statement and that will be executed. That particular line will be executed. Depending upon your a value, that particular case will be matched and those statements will be executed. That we already know and we have already seen in our previous sessions. Now, let's say if your a value is equal to 2 tick binary 1x, then what happens? Then no statement will be matched. Okay, then no statement will be matched. Let's say for let us see one example. Let me create one thing. Let me close this, create file. Let's say the design name is Priority Encoder. For Priority Encoder, I'm going to use Casex statement. So that's why I'm going to create that file directly. And using this file only, I'm going to explain you the Casex. Now, let us see how to use this Casex statement. So here I'm going to create something input. Let's say what are the inputs of your Priority Encoder? 4-bit input, 3 down to 0. D in, and we have our output as output 1 down to 0 y. Okay, these are my inputs and outputs of my encoder. Now output reg 1 down to 0 y. Now, so within an always block, what I'm going to do is always at the rate star begin case. What is my case is dn. Okay, case dn, if it is equal to 4 tick binary 000, then what happens? If it is equal to 4 tick binary 4000 followed by 1, okay, then what happens is my y is equal to 2 tick binary 00. Okay, and if my input is equal to 4 tick binary, wait a minute. Yeah, if my input is equal to 4 tick binary 0010, then my output is equal to 2 tick binary 01. Okay, and if my input is equal to 4 tick binary 001 0100, then my output is equal to 2 tick binary 10. And if my input 4 tick binary 1000, then my y is equal to 2 tick binary 11. Okay, this is the normal encoder design which we have written, and followed by default statement y is equal to 0. This is my default statement. Okay, and followed by end case, and followed by end. Okay, so this is my priority encoder which I have written. Okay, now let me first of all save this, and let us write down the test bench for this. Create file, tb underscore priority underscore encoder is my test bench, and press OK and finish. Press yes, and where is this tb underscore priority underscore encoder? Yeah, it has been created. Let us open this. Set as stop. So let us stop and open this file. Now, how to write down the test bench we already know. Let us declare the reg variables first. Reg 1 down to 0, d in. Sorry, it is 3 down to 0 d in. and my output is 1 down to 0 y. Okay, let me copy the test bench which is already written for encoder. Let us copy that tb underscore encoder. Let me copy this and paste it in my priority encoder code. Yeah, and here let me change the design name, that is priority underscore encoder. Design name I'm going to change it to priority underscore encoder. Okay, d in comma y, d in is equal to 0. Yeah, so this will work. Normally this is going to work. Let us cross verify it again. It is going to work or not. Let me save this. The priority encoder, what I've written is I've used a case statement, and the test bench I've copied it from the normal encoder design, and I've pasted here. That's it. So let me first of all save this design. Where is this? Okay, let me save it as tb underscore priority underscore encoder. Let me save this again. tb underscore pr underscore encoder, and let us make it as a top model, set as top, and run the simulation. Let us once cross verify whether it is working correctly or not. Yes, so this is my priority, this is my design which I have written. Okay, so if my input is equal to 0001, then I'm getting output is equal to 000, and if my input is equal to 0010, then my output is equal to 01, and if my input is equal to 0100, then my output is equal to 10. This is we already know, right? Now what I'm going to do in my design, in my test benches, I'm going to apply a input that is nothing but 000x. Okay, so I'm going to apply a input that is nothing but 000x. Now let us save this and let's see what is going to happen. And my priority encoder design, what I'm going to do is default y is equal to 1 instead of default y is equal to 0, and I'm going to write down default y is equal to x. Okay, I'm going to write down default y is equal to x, that is don't care. Okay, so let me save it first. And I'm basically giving my in my test bench input as 0001, sorry, 000x. Okay, let me show you again after running this. So in my test bench, what I'm doing is I'm providing 000x, and in my priority encoder design, default statement what I've given y is equal to tick binary x. Okay, let us see what we are getting at our output. So if my input is equal to 000x, then it is treated as don't care. Then it is treated as don't care. Okay, and my output is also I'm getting as don't care only, because if you see 000x, if you substitute the value of x, it will become 0001. If you substitute x value as 1, it will become 0001, that is nothing but 1. And if you substitute x as 0, then it is nothing but 4 zeros, that is it is nothing but 0. So it is a don't care value. Okay, so that's why your input is equal to don't care and your output is also don't care, because the default, it is not matching with any case statement. It is not matching with any case statement which you have written. That's why you are getting your output as your default value, that is equal to don't care. Is it clear? Any doubts or any queries here? So input, since your input is not matching with any statement, any case statement which you have written, so that's why you are getting your output as your default statement. Okay. Now let's say if you are using your Casex, let's say if you are using your Casex, and let me save this and relaunch it again. Let's check your output, what you're getting. So here also you can see if your input is equal to x, that is nothing but 000x. Okay, it is matching with the very first input. It is matching with the very first input, that is nothing but 0001. That's why your y is equal to 2 tick binary 00. So from this conclusion you can come to a conclusion that there is basically difference between your case and Casex. So if you are writing case of let's say Dean, and if you are writing 2 tick binary, 4 tick binary, sorry, 4 tick binary 0000, y is equal to 2 tick binary 00, sorry, 4 tick binary 0001, y is equal to 2 tick binary 00. and here you are writing Casex din, and if it is equal to 4 tick binary 0001, then y is equal to 2 tick binary 00. Okay, and default in both the cases you are writing y is equal to x, and here also default you are writing y is equal to x. Now in this case, if your din is equal to don't care, that is 4 tick binary 000 x, then here it is not going to match with this case or any other case, because you are using simply case statement. So it is going to match with the default statement, and your output will be is equal to don't care, because it is a default statement. But in the case of your Casex statement, if your input is equal to 4 tick binary 000x, this is going to match with this statement because you are using a Casex statement. You can compare your x value. Your x value will be treated as 0, or it will be treated as 1 by the compiler, and it is going to match with this particular statement, and your output will be equal to 00. So that's why in your output you can see your output as equal to 00 in this second case. Is this clear? The difference between your case statement and Casex is clear? Any doubts or any queries? Okay, now let us see how to design this priority encoder. Now, in the case of your priority encoder, the very MSB bit will have the highest priority, followed by the second bit, and followed by the third bit, and followed by the least significant bit. Now, here the least significant bit has least priority. So, if this the before bit becomes 1, then if you keep this LSB as 0 or 1, your design should not get any output. So, what you can simply do is you can write X. Okay, and you can refer the truth table also for the priority encoder. So for your priority encoder, you will have your truth table as 0001. Your output y is equal to 00. And if your input is equal to 001 and x. So if your second bit is equal to 1, then LSB bit, it may be either 0 or it may be either 1. It should not having any effect on this. So that's why your y is equal to 01. And if it is equal to 01 x and x, then your y is equal to 10. And if your very first MSB bit becomes 1, then all the bits, it may be either 0 or it may be either 1. Your y should be equal to 1 1. This is your truth table for your priority encoder that we are going to implement. How to implement? Simply we are going to write down if it is equal to xx and if it is equal to 1 triple x. Okay. Now what happens is you have written this particular statements, case statements you have written. Now, if your input din is equal to, if your din is equal to 4 tick binary 0001, then what happens? It is going to match with the first statement, and your y is equal to 0. Okay, and you are writing case x statement here, not case statement. You are writing case x statement with your din as your argument. Okay, now if your din is equal to 4 tick binary 0010, if your din is equal to 4 tick binary 0010, then this is going to match with this statement, and here 0 is here x is treated as 0. Okay, and let's say if your input din is equal to 4 tick binary 0011, then what happens? Then now also it is going to match with this second statement. Why? Because this x is treated as 1, and we have already 1 1 here present. So that here in this case also y will be equal to 0 1. And this is also our working of our priority encoder. What is happening here? Priority is given to this particular bit. You are not going to consider this LSB. It can be 0 or it can be 1. Your output will be equal to 0 1. And let's say if your input in is equal to 4 tick binary 1 0 1 0, then what happens? If your MSB is equal to 1, then this is matching with this, right? And your x can be 0 or 1, it is 0, and this can be 0 or 1, it is 1 in this particular case. It can be 0 or 1, it is 1 in this particular case. That's why it is going to match this particular case, and your output is equal to 1 1. So this is how you are going to use your case x statements. Okay, now let us run this particular thing. Let us run this particular thing. I have written already the test bench with this. Let me write it down as 000 0010 0100 and 01 and 1000. Let me save this and relaunch it again. Yes, now let us check our output. What are we getting? So we are basically getting if my input is equal to all zeros. Okay, for all zeros I will not get anything. And for 0, 0, 1, 0. Let me change it for all zeros. Let me change it. So here we can see, let me show you. So if my input is equal to 0001, my output is equal to 0. And if my input is equal to 0010, my output is equal to 1. And if my input is equal to 0100, my output is equal to 2. And if my input is equal to 1000, then my output is equal to 1. Now let me change the test bench. Let's say if in my test bench I am going to give 1001, then what should be my output? My output should be equal to 1. Let us see. Let us relaunch this and let us check. So my input is equal to 1001, that is 9. My output is equal to 3. This is how your priority encoder is also going to work. And for designing your priority encoder, you can use Casex statement. Yes. So that's all about this particular session. In this particular session, we have started with our discussion of encoder, decoder, and priority encoder, and we have also seen our Casex statement working. Yes. So that's all about this particular session. Thank you for watching this video.